Alright, so I'm going to do a quick little talk here about capacitors and the way they function. Um, a capacitor is basically two plates with an insulating dielectric in between them. And the purpose of those plates is to store an electrical charge, right? So you can think of the two plates in a capacitor like a big electron tank. So what happens if you've got a DC circuit? So let's say we got a DC light bulb, a capacitor in it, and a switch. When we first close that switch and the current starts to flow, negative to positive, what happens is those electrons travel from here onto this plate of the capacitor, so they fill up the one plate of the capacitor, and once that plate is full, then no more current is actually going to flow in that circuit. Okay, so if you have a light and a capacitor and a DC circuit, what will happen is this light will start to glow. It'll be really bright for a second and then it'll start to dim. And the reason being is when this plate is fully empty, lots of electrons can travel really fast. And then after what's called one time constant, the rate that those electrons can flow drops by like 63%. Why? Because this is starting to fill up. And after 5 of those time constants, the current totally stops flowing because there's no more room on that capacitor plate. Okay? So that's why that we have time constants is when you first close this switch, um, this capacitor has no resistance, right? Lots of room for it to store charge. All those electrons rush onto this plate. Um, that causes the electrons that were sitting on this plate to get pushed over this way, and you will see a current flow. And then as soon as that plate starts to fill with electrons, then the ability for that capacitor to absorb electrons is diminished, right? Because the tank's starting to fill up. And that's why you'll see the current slowly um, drop down to nothing. So after 5 time constants, if this is a 12-volt source, then the voltage across the capacitor will be 12 volts. When you reopen that switch, well, now all these electrons that were here, that were stored up here, they stored when you closed the switch and you had your first current flow. Now, when you open that switch or you take the voltage away, well, now all these electrons, there's nothing holding them there, so they're going to rush back, and that's going to cause these electrons to come back, and you're going to see the same thing. You'll see when you open the switch on a DC circuit, you'll see the current stay at the same rate for a minute or a second, and then slowly drop down to nothing. And what's happening is we're just allowing these electrons to redisperse throughout the circuit.